Welcome to the first mum in the United Kingdom here in London, and I hope you're going to enjoy today. For those who've gone to any of the European mums, they've been absolutely fantastic. And the beer is free at 5 o'clock-ish after the raffle. Lots of free gifts. It's going to be fun. Okay, so why am I here up at the front? Is because of an announcement that was made by MikroTik about DFS becoming mandatory on their latest version of Router OS, which caused a ripple throughout the industry in the UK for those who use DFS. So that's why I decided to choose this hot topic. So where have I come from? One of the words that you might find up there as to where I've come from in my history, in my career, is I came from Ofcom. Whoops. And before that, it was the Radio Communications Agency, and I was part of the Radio Investigation Service, which meant that I was part of a team throughout the whole of the UK that went out resolving interference problems, either legitimate users affecting other legitimate users, or quite often illicit users that were operating outside the terms and conditions of an appropriate license of some kind, causing interference to some other service, usually a safety of life service. So that's the emergency services, aircraft, that sort of thing. Kept us very, very busy. During that time, in my time in the government, I got loads of pieces of paper, which was fantastic for covering up the holes in the wall. No examinations required. You just had to be awake by the end of the week, and you got given a certificate. Anyone who's ever gone on those training courses will remember those, I'm sure. And that's basically what I did for 25 years, gaining an enormous amount of experience and knowledge about wireless. I first got wind of MikroTik Router OS in around 2005-2006 because I was assisting a very close friend and family colleague now down in Guernsey, and he put a Wi-Fi hotspot in down on his marina for his boat so that when he was on the boat, just before he went to sail, he could pick up what the latest weather was, because there was no 3G, there was no 4G in those days, and in the bottom of the hole of a granite marina, you're not going to pick up any mobile signal anyway. So he put a little Wi-Fi access point up. And then he found that everyone else realized that he had Wi-Fi up there, and they all wanted a share of it, and then he suddenly thought, I can make some money from this. How the hell am I going to do it? And that's when I did some research for him, and I came up with this MikroTik router board. It was a 532. Wow, it's amazing. What can it do except make the coffee? I then realized after about a year that I didn't really understand it very well. I mean, I got a good idea of what I was doing. I wasn't stupid, but I found after about a year there was so much potential to this product. There was so much things you could tinker with and play and make it stop working that I kind of guessed I could do with some training on this, to be honest. And that's when I went to MikroTik, who were actually doing the training in those days, and I got myself the certification in MikroTik, and then they then said to me, do you know what, Ron, you need to become a trainer. I says, why, what's in it for me? No, you need to be a trainer. Didn't quite realize what was in store for me, because I then subsequently became a trainer, and I've got all the MikroTik certifications, and working for Lin ITX, we provide all the certifications for MikroTik and a couple other vendors as well, which we can't be allowed to mention here today. So if we could just get this to work. Yeah. It's a layer 8 problem, as I call it. OSI 7-layer model, and it's a layer 8 problem. Okay, so we're proud to mention then that we are the largest UK distributor. We shift the largest amount of stock. We've got the largest number of certified consultants and the largest number of trainers, well, 2. But anyway, we've got 2 trainers, and we've been doing that since about 2010, 2011. DFS. Don't we just love DFS? It's that furniture company, isn't it? Always got a sale on all the time that ends tomorrow. And then you know the day after it starts again. So it's not true. Well, I think it's quite a good analogy, because I think that when it comes to DFS and MikroTik, the sale is finished. There isn't going to be another sale after this one. So if you're going to be using new versions of MikroTik Router OS, and you're going to be using Wi-Fi or wireless for point-to-point links, you're going to have to come across this DFS problem. Why do many of you not use DFS? There are problems with it. Let's have a bit of honesty. No one's filming you, they're only filming me. How many of you are using outdoor wireless for point-to-point and point-to-multipoint services on 5 gigs and have taken some step or some measure to turn DFS off? Totally honest. Yeah, about a third of you to about half. Excellent. I'll just pass the names on to my colleagues at Ofcom. It'll be fine. So what's the problem with DFS? The problem is that we weren't there first. The 5 gigahertz band was given to us as a freebie under some very, very tight controls, some terms and conditions that came with it in the small print. And in the actual paperwork that came with the allowance around the world to use 5 gigs for Wi-Fi or for point-to-point links, indoors or outdoors, it came with a caveat that we had to make sure that the new users of those 5 gigahertz services had to protect the legacy users who were there before and had been there since the first International World Conference just after the Second World War, which was an idea that got formed from the League of Nations and the United Nations. They thought it'd be a good idea to start regulating the radio spectrum. And 5 gigs was allocated for radar and for satellite services, set aside for it. And so what they said was, well, we'll go to these users and we'll double check with them what they want to enable Wi-Fi to be used. And the Wi-Fi vendors, the people who are actually physically going to be manufacturing the equipment and selling the kit, were saying, well, it's very low power. Most of the time it's going to be indoors anyway, so there's going to be quite high levels of attenuation from the brickwork and the roof. It's not really going to make its all way up to the satellites. So the satellites community, those who are using satellite links, Earth to satellite, were saying, okay, that's fine, but we will have one stipulation, which is that we want the spectrum to be used evenly. We don't want everyone to just use one frequency. So you can have a nice good chunk of radio spectrum, but you've got to even out, you've got to have a method, you've got to have some kind of a system to make sure that the spectrum, the energy that's going to end up going upwards, is fairly evenly flattened out across the band. So that was put into the spec. The other users was some radar users, and that was maritime and military. And they also said, well, we'd like to have it flattened out across the band, but also we want to make sure that if they pick up a radar signal, then they go and pick another frequency randomly from some other part of the band so they don't interfere with our radar systems that have been there since the 1950s. And it was rubber stamped and agreed, and the vendors said that they will implement DFS and it will all stop that from happening. Everyone was happy. And the problem is we found out that life wasn't quite that wonderful. Why have things changed now? If you actually look at the technical specifications for DFS, the ETSI specifications, they have changed significantly in the sort of 15, 17 years that 5 gigs has been operational. But DFS has always been there. It's just that what's been happening over the last 17 years is that the technical spec for it has been tightening and tightening and tightening, and the wording of the legislation has been getting stronger. It's no longer saying things like, you should use DFS, which in legal terms means basically you can avoid it and don't have to do it. It now says, you shall, which now means it's mandatory. You can't have a choice in the matter anymore. And then they found that people were finding that there was a tick box you could untick or tick, or a drop-down menu that they could choose to have it on or off. So they've now changed the wording of the spec again and said that that control by the end user shall not be possible. They've actually now put that into the wording of the regulations. So what's been happening over the years, slowly, piece by piece, is they've been shutting the doors and making it more and more difficult to get around these problems. So what's actually happened then over the last 17 years is that those original legacy users have been getting more and more interference. 5 gigs has taken off. We know how rubbish 2.4 is. Internet of Things is going to make it even worse. So 2.4 gigs is just a noisy mess of garbage. But 5 gigs is getting very, very busy as well, especially for you guys who are running outdoor WISPs if you are certainly in an area that you're competing with other companies who are operating 5 gig services in the same patch that you are operating in, it's getting more and more difficult to find clear spectrum that you can operate your services to your customers in. So it's getting more crowded. That's increasing the amount of energy in the 5 gigahertz band, so effectively the noise is going up. And also, it's increasing the chances of somebody treading on top of a radar signal and being seen. Because there's just sheer numbers, there's more of you out there, there's more signals, so the level of chance has now increased. The other major problem that happened was that when they brought in the legislation for 5 gigs, nobody bothered asking the biggest user of 5 gigs radar. Nobody actually thought it'd be a good idea to talk to the meteorological departments around the world. And they were oblivious to this and didn't really realize what was going on around the world until it started affecting their radar signals, and then they started asking questions. How the hell did this happen? Well, you didn't get invited to the meeting. We're going to get invited to the next one. And in fact, they went to enormous lengths to make sure that they got the regulations tightened up to their benefit. One of the things that then happened was that because they complained to the regulators about the levels of interference that they were getting from us guys, was that they called upon the regulators to do something about it. Now, the beauty of the way in which the legislation was written within the EU is that the directives have got a very, very powerful clause. There is an Article 9 statement that basically says that if there's a problem, they can come down on the manufacturer, the importers, and anyone shifting the equipment around in Europe like a ton of bricks and stop it dead in its tracks. They can basically give an order to anyone involved in the supply chain, from manufacturer to the person who sells it to the end user, and say, you can't sell it anymore. That hurts. You imagine if you're the manufacturer of a device and the EU comes to you with a nice little letter from Brussels and says, if you don't do something about this by this date, you are now being banned from being able to sell this equipment anymore. Now, all of a sudden, you wake up and you pay attention and you do things. The carrot to that legislation is that there is no barriers to trade. And we've always heard this phrase, isn't it, within the EU, that there's no barriers to the free movement of goods within the EU. That's allowed, as long as you play ball. As long as you abide by the regulations, no one will do anything with you, nobody will touch you, you can just crack on and sell and shift as much kit as you like. But the minute that the EU gets wind of the fact that there's a technical problem with the equipment not complying with the regulations, and therefore is not compliant with the CE mark that is applied upon it, the ultimate sanction is to cut you off. I'm not saying that's what's happened, but that is the power that the EU have got. So, I'll quickly go over the history. I've actually got a hell of a lot more slides, and they'll get printed up on the website as a PDF, and you'll see there's a lot more technical information in there, because I've actually got a good hour and a half to 2 hours I can do on this, and I don't want to bore you with all the technical detail. You're probably waiting for me to get onto the tips and tricks bits of how you get around this. How did it start off? It started off back in 1991, and there was a recommendation that 5 gigs should be used for Wi-Fi. There was also a thing in there about 17 gigs, which made it into most of the European Union, but we here in the United Kingdom have got legacy users on 17 gigs who put their foot down and said, we're not having 17 gigs used for Wi-Fi. So I know you can buy 17 gigs microwave link equipment, and you can use it in places like Ireland, and in quite a few countries in Europe, but here in the UK, 17 gigs is not available. But the magic one was 5 gigs. And what they said was, we think that ETSI is a good body to come up with the technical standards required. So they then consulted with ETSI and came up with a specification and a recommendation, and they then published and said, yep, go ahead, you can use 5 gigs, indoors. No outdoors at all, just indoors, because then you've got the attenuation of the building and the satellite users will not get upset. But then they said in 1998, we want more. Isn't it? It's like Fagin, please, sir, I want some more. And they realized that the vendors realized that 5 gigs was fantastic, but they needed more spectrum. They wanted more radio channels. So they went back to the legislators and said, we want more. And about a year later, they got given more. But on the understanding that we still had this catch, which is that it has to have DFS to protect military radar and satellite uplinks. No mention of weather radars whatsoever at all. If you actually then read the actual clause that got put into the final spec, you can see that there is no mention at all about weather radar. And yet it's the weather radar that's the biggest losers in this at the moment. Because remember, DFS is not just about radar detection. It is also about the random selection of a radio channel, which is a killer for you, because if you're doing point-to-point links, you've probably nailed it to one frequency because you thought, that's a good one. I like that frequency, and yet in fact, it's in the spec that you have to allow it to work it out for itself across the whole of the band. You're not supposed to be able to override the choice, and we all know that we can. Then there was a world conference, the whole of the world then gained 5 gigs. But the thing was that they still tied it all back to an original ITU recommendation for how DFS worked. Recommendation M1652, which was something from like the 50s or the 60s. It was a very, very, very old DFS specification, and it was not fit for purpose. They didn't realize that at the time, not until the interference reports started. One of the cool things, though, however, about the actual technical specification was it was actually all written into it that they should continue to modify the specification. It actually had it written in there that it wasn't a static specification. They said that further studies should be made and should get feedback from users and from legacy users, and it should therefore keep in touch with the real world of what's actually going on. So that's what happened. If you look at the ETSI specification for this, it is now up to 1.8.1, and it started off at version 1. So we've had about nearly a dozen different versions that have come out over the years. It's been constantly being changed all the time. Yes, we should have radar detection. And that was the problem. By the time it actually went live, it was already out of date with the type of radar technology that was being used at the time when it came out. That's what it said just now, that taking into account practical experience. This is the thing about the standard, taking into account what's actually happening on the ground, what's really happening, and as a result of that, feeding it back into the system so that the spec was constantly being changed. The problem was that the meteorological organizations were never consulted, especially in Europe, and they were the ones who were getting most of the grief. At the original conference in 2003, there were some countries who had representatives, which was Australia, America, and Canada. And their meteorological services did not like the idea of any kind of DFS solution. They looked at the DFS solution that was put into the technical spec, and they didn't like it. And they didn't feel that there was enough protection mechanisms in there in the spec to make sure that their radar systems would remain uninterfered with. So they took the easy option for them, and they just said, right, it's banned. You can't use the same slot of frequencies that's used by all the weather radar, which is why we have this, if you ever Google anything about weather radar, you get a lot of information from the States, the TDWR information, the weather radar that's at nearly every American airport, and the band is actually locked out. You're not allowed to use 5600 to 5650 at all. The sub-band is notched out. It isn't in Europe. We can use it, because of course we believe that the DFS works. But there again, we didn't actually ask the meteorological organizations if it works. Found out soon enough. So the Americans, the Australians, the Canadians, they all banned it, and we just carried on blindly going on with it. To the point now where even the meteorological organizations know that they can't put the genie back in the bottle. They can't request the European standard to be modified. Now it's too late. They can't ask for that band to be notched out and removed from the Wi-Fi band because it's just too heavily used now. It's too late. Should have done it back in 2003, but it's too late now. But is it important? Do we even need to worry about the interference that may be potentially caused to the weather services? Very much so. They are actually seen by the UK government as an emergency service in the same way as you want the emergency services to come to your aid as quickly as possible if you require them to come to you. They want the police, the fire, ambulance to come to you as quickly as possible. Anything that impedes their progress can cause lives to be lost. And the same thing applies to weather. We get quite a bit of rain in the UK for some weird reason. I think there's a large lump of water in there between us and the United States. And we get a large amount of water. And therefore, the ability for the UK Meteorological Office and other European countries as well to be able to predict many, many hours in advance where the rain is going to fall and by how much means that they can then warn those emergency services. They can warn the Environment Agency. That then in turn means that they can put flood alerts out, and they can then warn us and our homes to be better prepared for anything that might happen in the next few hours or over the next 24 hours or so. It can alert the utility companies, because then they know when there's going to be a gap in the rain. They know when there's going to be a chance for it to stop at long last so that the engineers can get to the locations to fix the problems where lightning has taken some kind of service out. It's a very, very important service, which is why when the Meteorological Office gets interference, they ring Ofcom. And Ofcom will immediately respond. It's a safety of life service, which is why when you get the phone call from Ofcom, which is usually done on a very gentlemanly, very diplomatic and very pleasant way, they go, is there any chance that you might be using 5625 and it has this SSID name, which is the same as your company name? Could it be you? Possibly? Any chance? And you go, might be. Why? Well, just because you're interfering with the weather radar and you're thinking, oh, okay, but it really is important. And you do need to do something about it. Because the ultimate sanction is Ofcom will eventually come and knock on your door. And they give you a beautiful little piece of paper as a little receipt for all the stuff that used to be on your roof at one time. And then your business has gone down the pan. So they do it softly, softly. You know, you can always ramp up the enforcement. You don't go in heavy-handed, gun-ho, all guns blazing. You start at the bottom, you do it polite, you do it gentlemanly, you do the request, and if the problem's gone away within 15, 20 minutes, case closed. Excellent, on to the next job. Whereas if you don't respond and you don't do anything about it, right, okay, we're going to have to go and visit them. Now it starts to become a little bit more aggressive. The next one after that is they get warrants. Magistrates will issue warrants 24 hours a day, 7 days a week, even Christmas Day, New Year's Day, whatever. There's a duty magistrate available. He'll sign the warrant off. And then there'll be a knock on your door at some ungodly hour, and you've now got to find keys, you've got to find key holders, you've got to get to the kit, you've got to now deal with it. And it then becomes more inconvenient. There's also a very clever piece of legislation which says that they can nominally seize the equipment. What they then do is they say, right, you've got to turn that piece of equipment off, you can't turn it back on again. If you do, it's contempt of court. We've seized it. So if you turn it back on, you are now, in contempt of the courts, because you're now modifying the evidence. The evidence is there, leave it alone, don't touch it. It must stay as it is now until we see you in court, which could be 6-9 months down the line. Can you survive an outage for that amount of time? Be nice to them, okay? They've got a hard job to do, there's not very many of them left, and they're absolutely struggling to keep up with it, so be kind to them. Aircraft need to know about the weather. CAA need to be notified. The MOD do their own air traffic control, so the MOD need to know about the weather. They don't use weather radar themselves. They don't like they have in the United States. They don't have a 5 gig weather radar at every single airport. They rely upon the Met Office's system to provide them with the weather reports. We don't also have the same problem they have in the States with wind shear. Highways Agency, they need to know about the motorways. Is there going to be a really terrible, massive, sudden downpour in a certain, then in which case they can put the warning signs up to say, slow down, which we then all ignore, because we can't see the rain, so we may as well just keep going at 70. Coast Guard Agency, they need to be knowing about the weather out at sea, and therefore keep the shipping safe, and put out announcements to shipping out at sea that there's going to be really bad storms. It's really, really important. It's definitely safety of life. So because of all the interference, the European organization called EUMETNET, really sexy name, They got involved in working out how can we fix this interference problem, and they took upon it in two ways. They actually did a practical study. They literally went to the kit, looked at it, and found out what could you do. And they found that it was really easy to circumnavigate around the DFS settings. And they found that the vast majority of vendors at that time were not making DFS mandatory. And yet in the regs, it said DFS was mandatory, not optional. So that upset them a bit. But it also illuminated them, and it made it explain to them as to why we've got the problem, because you can turn it off. The other thing they discovered was that the radar systems that they had installed for many, many years did not match the radar signatures that were built into the ETSI spec. There was no real correlation with it at all. So therefore, even if you had enabled DFS detection, you wouldn't have seen the Met Office's system, you wouldn't have triggered, you wouldn't have turned off that radio channel, the system would not have been automatically avoiding them anyway. So it didn't work. The major problem was the pulse width wasn't small enough, and the PRF was wrong, the pulse repetition frequency, how many pulses of radar energy are going out every second, was completely askew from reality. So they came up with a whole load of modified changes. The ETSI spec got modified again, year upon year. Over the next few years, it kept getting tighter and tighter. And the other thing that they did in a big way was they said, you're not listening for long enough. A weather radar does not work like a air traffic control radar. You've seen the thing that goes around really, really fast, usually painted bright red or orange, which is a primary surveillance radar, which is just looking for aircraft. It's looking for lumps of metal in the sky. And that is spinning around quite fast. A meteorological office weather radar doesn't do that. It actually goes around very slowly, indeed, in incremental steps, in a helical shape, in a spiral. And so therefore, the radar is only looking at you or your base station maybe for just 1 minute in an entire 30-minute window. Because for the other 29 minutes, the dish is pointing the other way and you don't see it. So it's a completely different animal. So they said 60 seconds is not enough time for the receiver in the Wi-Fi unit to pick up the radar pulses. So they want that increased for a start off. So they said we want that increased to 10 minutes. The other thing is they found is it's just not accurate enough. In the actual meteorological office band, the 5600 to 5650 band, we want it to have a much higher probability of being able to detect the radar pulses. In the spec at the time, it was a 60% chance of it being successful. We want it up to 99.99%. Big leap. Anyone who's ever tried to do reliability of links from, say, what they call 4 nines to 5 nines, reliability, just going one extra 9 on the end is a massive amount of extra reliability. The other thing that they realized was that they do a noise floor calibration spin. The radar goes round the whole of the sky measuring just the background noise level. It's not transmitting at all. And so what they agreed was what they would do is every now and again they will transmit test pulses out into the air as they're doing the noise calibration procedure so as to increase your chances of picking up their radar when they're doing the receive-only path, the receive-only bit. So we're now on 1.8.1. And on the top band C section, we're up to 1.2.1. That one's hardly gone through any changes at all. I will flip through these because you can read these later. So after making all these massive changes, did it make the slightest bit of difference? No. 12 countries in the EU are regularly reporting interference to their regulatory authorities, and in the UK that would be Ofcom. It is a major problem. Hungary reported for one entire month their system was down. It was getting so much interference they couldn't pick up any rain. They couldn't tell the difference between a Wi-Fi signal and whether it was a lump of water in the air. What does it look like? If you can go to any of these countries' websites and you can see it every single day for yourself. That's the Czech one. That is not rain. That is a Wi-Fi signal. You can see the pulsed transmissions from the WLAN system, and it's then seen as lumps of water in the air in a single line going away from the radar. There's the radar site. So the interfering signal is somewhere along that line, like a direction finder beam. The Czech Republic have got so much interference that they actually publish a bad list. They actually now are using their radar to receive the SSIDs, and they're publishing all the SSID names, MAC addresses, SSID, and radio name is being published on their website every single day. And I looked at it the other day, and there was 40 different links that were being on that URL. Spanish radar, nice good beam of garbage there coming through. That's not a block of rain. Spanish again, nice good beam of interference. Belgian radar, definitely interference, that's not rain. The French getting it. Latvia as well, loads of interference from 5 gigs users. Here's one in real time. You can actually see here how the bands of interference keep appearing. And they're all pointing back towards where the radar site is near Bucharest. You see them there? How about the good old UK? Yep, UK gets it as well. Okay, looks sexy. There's another one just towards the end. So this one's affecting an Irish radar site, which is teed in with the UK system. They get shared with the UK authorities. They get the data fed through to them. It'll come up again just towards the end. So somebody, somewhere, in the Irish Republic down there is causing interference to the Met Office. And what's the name of the regulator down there? Comrep. So they'll end up making phone calls and ringing around and try and find out who the guilty person is. It'll come up again in a second. So what's happening is the radar is going round slowly over a 30-minute window. So it's taking quite a long time, because you can see here in 5-minute increments. The next time the radar is coming around and looking at the point-to-point link that's causing it, here we go. Okay, that's going to make it difficult for the weather analysts to actually work out whether there's any rain there or not. So there was a working group, and they came up with, they just said, right, in a typical year, can you send us a report into the EU of what you've had to put up with? And this is a list. So in Latvia, for example, there's been 23 reports of interference, up to 20 kilometers away from the actual radar site. In the United Kingdom, they've had thousands of reports. The UK Ofcom has had so many reports that they lost count. They didn't bother sending them to the EU of every single report. They just said, trust us, we've had thousands of them. We actually physically went out the door and chased down and found the source of 24 of them, because they were on the air long enough for us to be able to get the Land Rover out and find where it was actually really coming from. Because we couldn't figure out who it was, we had to go and do it the hard way. But you can see up to 100 kilometers range. Those radar have actually got about 150, 200 kilometers range. So in the Ofcom one, what did they actually discover? They found 2 wireless point-to-point, 2 wireless cameras. So they just educated the engineer to retune it to a different frequency and 5 gigs. They came across 8 WISP point-to-point links. 3 of them had DFS enabled, because they had them disabled, and 5 were just simply retuned. So that's the 8 of those sorted. A cell phone enhancer. That was not Wi-Fi, that's someone using an illegal amplifier. It was causing interference on 5 gigs, so that was removed by the enforcement team, and they were left with a pretty little piece of paper which said, we own it now. If you really want it, see us in court. Masthead amplifier, a masthead amplifier on the top of a UHF TV aerial? They go quite often into they go into like a self-oscillation mode. There's such a high gain amplifier inside them, if water gets into them at all, it effectively like shorts it out, and the thing will actually take off. It starts self-oscillating, and if you look at it with a spectrum analyzer as you drive down the street, it's not very difficult to find. strongest in the direction of where the aerial is pointing, because that's what's now amplifying the direction of where it's feeding. So obviously there was a masthead amplifier that was causing interference. There was a military radar. It was non-standard, it was non-compliant. It did not actually comply with the regulations. So even though it's the military, Ofcom still have got the ability to say to the military, no, you can't do that. There was an unknown military one again, and 10 that they never did find where they were. They just couldn't get to the bottom of it, and there comes a point where you just have to call the dogs off. You know, they're not causing interference anymore. We can just write this off. We're never going to find it. We're spending more and more time looking for it, and we're not getting anywhere. So where are all the radars? Well, in the UK, you can get that from the Met Office website, and also from a really good one, which is the EUMETNET site. They list every single radar site in their organization with their frequencies and everything. Here is the UK list of the EUMETNET. You can see the exact frequency that they're operating on. Jersey has declined to comment. But every other one, all of the others have all got their frequencies and their lat longs, so you can then plot them on your own whatever system that you've got for where you've got all your base stations located. You can then figure out whether an antenna is pointing in that direction or not. That is the spec of a radar. Look at the size of the dish. It's a 4-meter dish. They're running 250 kilowatts on the transmit side. 150, 200 kilometer range. It's a helical scan that I was saying before. It is not just a spinning round and around very, very fast. It's a very, very slow scan. So it takes about quarter of an hour to do one scan, and they use two different pulse repetition systems, one slow, one fast. How wide is a Met Office radar? It's about 30 megs wide. Can't see it on this graph because it's just off the edge, unfortunately, off the right, but there's another lump of energy about 100 megahertz higher up. So you've got the main lobe of energy on the frequency that they're licensed for, and also 100 megs further up, so that would be 5700-ish. There'll be another lump of radar energy. So if you're operating in band C, or right at the top end of the band, you can still get radar detection hits from a radar that is not on your frequency, but is actually on 5600 something. That is just magnetrons. That's the way they are. It's the nature of the beast. Magnetrons will generate the majority of the RF on their designed frequency, but they will also generate RF about plus 100 megs. Ofcom and the Met Office are slowly organizing a way of tightening up the specifications so that they can filter out, with a cavity filter, the 100 megs. But it's a bit difficult. We're talking about plumbing now. This is real mechanics. This is big boys stuff. You know, it's not just a case of making a little capacitor and a resistor and creating a filter. This is 250 kilowatts of RF and needs large amounts of tubing. Oops. Quickly go over the DFS process. There's two.
Attention, please. Attention, please. Please leave the building immediately. DFS Radar. Please leave the building
Thank you.
immediately following this exit. Do not use the lift. Attention, please.
1, 2, 3. Okay, guys, if we can settle down. Thank you for your patience. Part 2. Well, what we just suffered there was a radar detection, and we had a 10-15 minute outage, didn't we? Thank you for that demonstration. So, what does DFS do? DFS has two major component parts, which is that before it becomes operational, before it allows the wireless to start transmitting, it just listens only. Different amounts of time, usually a minute for the majority of the band, but in the 5600 to 5650 slot, it listens for 10 minutes, because it takes a while for the dish to come around. So after 10 minutes, if it has not received any radar pulses, then it will bring the transmitter up alive on that frequency. It will then continue to listen in between transmissions. So every time the thing is receiving, usually an Atheros chipset, in the case of MikroTik router S, the Atheros chipset is constantly looking out for radar pulses. And if the Atheros chipset gets a hit, it will then pass that information through to router OS, and then router OS can then make a decision as to what to do about it. If DFS is disabled, it ignores it. If DFS is enabled, which it is now, mandatory setting, then it will kill the operation of the transmitter. It just goes off air. And it will now go to the next frequency in the scan list and see if there's any radar on that for a CAC time. And if you're in the 5600 to 5650 section, every single time it will listen for 10 minutes. That can be quite a lot of outage time. One of the things about the way the regulations has been written is the regulation says you don't have to do a channel availability check if you've already done one recently. So in theory, what the regulations say you can do is that whilst you're actually operating on the frequency you're actually on at the moment, you can check the other frequencies as well. So in parallel, you can hop off in the spare air time, and you're allowed to check the other frequencies to see if there is any radar on those. So you can do the CAC, the channel availability check thing, during an operational ISM phase. Router S doesn't do that, but the regulations allow you to do that. So that means that when you do hop, because of a radar, you don't have to be forced into doing a whole brand new 10-minute wait. You don't have to. The regulations say if you've already done it already, because you've looked ahead, then you can use that information to start going straight into ISM, the in-service monitoring state. What's the biggest problems with DFS? Is false positives. False positives is the biggest problem that has caused so many operators of wireless links to disable DFS. You don't know whether they're false or true. You don't know if you've really picked it. It's not like in the log it says detected Meteorological Office Thurley radar site on this frequency, and you look it up and go, oh yeah, that's it. Yeah, that's the frequency they're on as well. It just simply says radar detected. But was it? What it really means is we think radar was detected, because that's what the chipsets told us. The chipsets told us that it's receiving these pulses, which matches the signatures that are embedded within the ETSI specification. So I'll believe it. If it says there's radar there, I'll take its word for it, and it will then trigger a DFS change of frequency. The problem is that these triggers can cause quite long outage times. You can be having a link gone off air for easily half an hour. Especially with other vendors' equipment, they can be offline for a long period of time. And if that's a backhaul link, and it's carrying a few hundred megabits of traffic, and you've got no other links running in parallel, you've got no redundancy built into the system, that's a very long, embarrassing silence. Well, it won't be completely silent because your phone will be ringing all the time from customers saying, you've got no internet. So that's why a lot of them ended up hacking the firmware or finding ways to get around it. The other problem is using older firmware meant that it then became vulnerable to virus attack. We all know about an event that happened over the last year. It actually also happened a couple of years back as well. It was the same firmware, the same vulnerability, it just got hit twice. One ISP was out for over a week, fighting desperately to get their systems back up and running again because they just get wiped. Part of the virus attack is that it wipes the whole config, and that's your whole network just gone down the tube very, very quickly indeed. Within minutes, the whole network was around their knees. So that has caused the industry to look at it and go, we don't like DFS, I'm turning it off. But why are you getting false positives? One of the biggest reasons that I have seen for false positives is because you're all running, those who are getting it are running far too high transmitter power. Easily, I've seen point-to-point links being used with 30 dBi or greater dishes. They're running at the maximum output power of the radio, and that actually calculates in at about 1.5 kilowatts. I'm glad I'm not climbing the tower and walking past the front of that dish. 1.5 kilowatts is a very, very high level, and it's illegal anyway. You're only allowed 4 watts. There's a massive jump in difference between 4 watts EIRP and 1.5 kilowatts. And the downside to running these high powers is, yes, you can do a link that's 20, 30 miles long, and you can get some decent throughput out of it, and you think that's fantastic. This kit is brilliant, this stuff. The downside is the reflections you're getting from nearby reflective objects. The end of the transmission that the radio is transmitting with goes off air. It then switches into receiving mode, because it's a half duplex system, and what it then picks up is it picks the tail end of itself reflected back off some object nearby, and it then thinks that's a radar pulse. It's a misdiagnosis. It isn't really radar, but that's enough. We're out of here, we're gone. DFS result, that's it, we've triggered, we go off air. So by just simply turning the power down, 2 things will happen. We've found consistently that by turning the transmitter power down, you won't get any DFS triggers anymore. The second thing we found is the link drops out and doesn't work anymore. But that's because it was engineered wrong in the first place. Okay? If you're going to design a system that's illegal, it is going to come back and bite you in the backside at some time in the future. You are, working on borrowed time. But that's the problem. Very, very, very common problem. Reflective surfaces, solar panels on rooftops, the edge of a building, if you're mounting it too close to things, they reflect, and you will get that RF come back to you. And because you're running such a high amount of power, the reflection may be only very, very weak, but it's enough for it to think that it is a incoming radar pulse. So by turning the power down, you then make the reflections go down. You don't hear them anymore. So you don't get the triggers anymore. The other thing, of course, is keep up to date with the latest firmware revisions, because the vendors, the actual manufacturers of the equipment, are getting wise to these false alerts, and they are writing new code. If you complain, if you raise support tickets, they can then look into it and try and find a way of making it less sensitive, but still trigger legitimately with legitimate radar, but less so often with false error type transmissions. So make sure you keep yourself up to date. So where are we at now? We've now got it on 637. The announcement went out in the changelog, which I have to applaud. The verbosity of the changelog is fantastic. I was one of the ones that for many years kept complaining about the changelog, and it would say, we fixed something. I found a changelog going back very to the early days, and it just said, we fixed some bugs. That really helps me. But now we've got a cracking, brilliant system now where everything is listed. And in one of those, DFS is now mandatory. So what do we do? The problem is that when it now turns on the operating system, when it boots up, the transmitter will stay offline and it will do a CAC. If you're inside the 5600 to 5650, then it will sit there for 10 minutes. If it's anywhere else in the band, it will do it for 1 minute. If it finds radar on the frequency that you've got programmed into the frequency field, it will then start going to the scan list. Now the scan list, if you haven't edited it, it will have the first entry as 5180. If it's an outdoor point-to-point link, what are you doing operating on 5180? Not permitted. But it will operate on 5180. No DFS, no CAC time, she'll come up straight away, and you'll suddenly find that all your links are on 5180. So edit your scan list and make sure that the scan list has actually got legit frequencies in it for, in the UK, Ofcom bands B and C, not band A. The other thing is that the DFS checks in RouterOS are only performed on the AP. So the actual AP or AP bridge or bridge mode is going to actually be doing the DFS checks, not the station end. This has come about because in the regulations it says that you have a master and a slave. If the master is in control of the frequency that the channel is going to be operating on, then the slave does not need to actually do a DFS by itself. So the slave is getting the information from the master.
Good morning, ladies and gentlemen. We would like to thank you for your quick response to our emergency situation, which now has been dealt with. We apologize for any inconvenience caused and wish you a lovely day. Thank you.
Thank you. So, if you have got a radio operating in any of the station modes, station bridge, pseudo bridge, all the other wonderful modes that you've got, they do not do a DFS check. Make sure that you are not operating in the actual band itself, where the vast majority of weather radars are. Try and avoid those frequencies if you can. Try and stay out of 5600 to 5650. If you're going to be deploying a new link, have a look at the direction in which the antenna is going to be pointing in. Remember, I've given you the links. You'll see them on the PDF when you download them from MikroTik. The EUMETNET.
We would like to thank you for your quick response to our emergency situation, which now has been dealt with. We apologize for any inconvenience caused and wish you a lovely day. Thank you.
Best of three? Right. This is what you get with DFS, isn't it? Constant interruptions. This is a beautiful example, but it's not what I wanted. Not what I wanted. Okay. So make sure which direction you're firing the antenna in, check against the map, look to see if you've got a weather radar in that direction. If there is one, don't use it. Or flip the link around so that the AP and the station is the other way around. You're still potentially going to be causing interference, remember, because the antenna at one end is still pointing towards the radar station. There is still a risk of damage being caused by interference, but you won't know about it until you get a phone call. But at least it won't keep getting triggered. So it's not the best advice, but you know, if your back's up against the wall, you know, sometimes you've got to do these things to get you out of trouble quickly, and then you think that I'll try and sort out next week, which then becomes next month, which becomes never. But I know what it's like. Ultimately, I can see this being a real bad thing for 5 gigs. A DFS is a danger, I think, to the 5 gigs usage, because we're going to end up having to just push more and more stuff onto other radio bands. We're going to have to leave 5 gigs. We're going to have to actually, we can use it for some parts of the radio spectrum, but certainly in very congested areas, you're going to have to start using other kit. So 24.1, the E and the V bands, light licensed scheme stuff, very low cost, £50 a year, and very suitable bands to use. Or you can go over to licensed equipment. Yes, there is Ofcom legitimately licensed 6 gigahertz equipment. There are 2 bands in 6 gigs, 6L and 6U, 6 lower and 6 upper. I'm not aware of any low-cost equipment being used on 6 gigs. I've checked the Ofcom register, and all I have found is very, 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 very expensive kit being used on 6 gigs. But there is spectrum available. You can use 6 gigs. If somebody wants to be the first one to give it a go to try and get a license for using lower cost equipment on 6 gigs, feel free to try. Otherwise, you're going to have to use the higher frequency bands, 13, 15, 18, 24, and then you're now talking about professional carrier grade kit. But that link will stay up. Once it's deployed, it will stay up. And you can get like 5 nines reliability out of it if you're not making it too long a distance. If it's longer distance links, you can get it to 4 nines reliability. But you know, you're talking about easily $1,000, a couple of grand license fee every year on top of the capital costs for the kit itself. It's the price we're going to have to pay. Bottom line, last thing of all, is if you really, really, really are sure that you don't want DFS, and you are able to sleep at night without any worries or concerns about the phone call from the regulators, you've always got super channels. But remember, how the system works, there's a latency involved in it. Every time we find a workaround, the regulators will shut the door on it at some point in time in the future. So even though you can use super channels, which then turns all that off, there will come a time, ultimately, when that will get taken away as well. The other last remaining thing, what about Capsman? That's a Wi-Fi controlling system. It's a fantastic Wi-Fi controller system. What's changed with that? Nothing, because it doesn't do DFS anyway. But again, for how long? MikroTik are not stupid. They are going to be looking into this at some time in the future. It's on their work list, and Capsman will also then have DFS implemented on it as well. But for the moment, if you're using Capsman to do a Wi-Fi deployment, say in a school, DFS is not going to be of a concern to you. So, good luck, and let's be careful out there. Thank you very much. Any questions that I can't answer? Any questions I can answer? Cracking. Next. Thank you very much.
Will be McRoberts, yeah.
Right. You want to use a microphone or do you want to use a headset?